So far, all of our microservices we've used haven't actually used the abstract repository pattern. So let's consider the scenario that we've built our entire application out and we find that our ORM is making suboptimal queries. The problem is that we've already set up all of our code base and all of our endpoints are sort of coupled to the data layer. So in this instance, the ORM we're using is Type ORM, and all of the methods that we're using from our services are coupled to the actual business logic itself. This means that if we want to change any of our methods, we have to go to every single endpoint and change the Type ORM method manually. Now, if we wanted to change our ORM, let's say we wanted to move from Type ORM to Prisma, or perhaps we wanted to write some raw SQL and have a custom method, our system will be coupled and this will be a tedious process. Now, the abstract repository design pattern solves this issue and it decouples all of the business logic from our services from the data layer. Let's say that we want to add another user to a user table. Now, instead of using Type ORM save method directly in the user service, as we have been doing so far, we can delegate all of the Type ORM specific data related operations into an abstract repository. So what this does is it decouples the data layer from the business logic in the user related stuff. The abstract repository itself is abstract and it can be extended by any entity. So in this case, the user entity can extend it, and then we can have all of the user related business logic in the user service itself, and the abstract repository can have the interaction between the data layer, separating the concerns. This means that if we wish to change our ORM or create some custom methods that we want to use, we can simply update the abstract repository class and those changes will propagate throughout our entire application where we've consumed those methods. For any developers that have experience in building APIs long-term or maintain APIs, you know how important it is, particularly on the back end, to structure the API properly from the beginning. If we don't structure the API properly from the beginning, it becomes a nightmare to change later on, especially if we have dependencies and coupled logic between various services. So separating these concerns is very important, and it's important to do that early on in the project. The abstract repository pattern is a specific implementation of the FACADE structural pattern outlined by the Gang of Four in design patterns. In NestJS is object-oriented, so awareness of all of the object-oriented related design patterns is really important, and it can help structure your application from the beginning so you can ensure that you have long-lasting and quality code base throughout the life cycle of your API. Put simply, structural class patterns are used to use inheritance to compose interfaces or implementations. The FACADE pattern provides a unified interface for a set of interfaces from a subsystem. So in this case, our abstract repository class, it's going to have the set of interfaces for the Type ORM subsystem, the interfaces that we're exposing, and we're doing so to decouple the business logic associated with the specific entity class that we're extending from the abstract repository method. So just before I get started implementing the abstract repository pattern in NestJS, I just wanted to give a shout out to one of the subscribers, Alejo. It was actually his idea to do this, and he actually sent a PR through onto GitHub. Really well done, really well communicated, explaining all of the benefits of this pattern. I've checked out his profile, and he studied computer science and he has a huge amount of skills here. So he's looking to collaborate with other developers. So if that's of interest to you, hit him up. And yeah, I just want to take this opportunity to say that this is, an open source project. Everyone's free to contribute if they wish. If you have any feature ideas or you see any bugs or anything like that, please feel free to send through a PR. And I think it'll be really exciting to work together and build out features together for this project. So with that said, let's jump into the code. So basically what we want to do here is we firstly want to set up our abstract repository here. And to do that, we're going to implement an interface for that. So this is the part where it's coupled to the actual ORM itself. So the interface itself, that's just simply the signature. And by the way, since this was a PR, I'm going to show code block by code block of what the code is in a logical order. So I'd really like and appreciate your guys' comments to see if you prefer this approach or if you prefer me typing it out line by line. I guess it depends on person by person, but I've had some comments saying that when I type things out, it might be a little bit too slow, and you guys may prefer this approach. But if this is too fast or anything, let me know, and I can switch back. So write a comment to let you guys know what your preferences are, and then I can adjust them accordingly. And of course, this code's all on GitHub, so you can just clone it if you have any issues at all following along. So basically, we want to create the abstract repository. And the abstract repository, for our case, we're using Type ORM. So we want to use all of the Type ORM methods. And we're going to name our methods that are coupled to the repository, and we're going to have an interface for those, which we can implement. So just to illustrate that, we've come to in the folder structure here. If we go into our shared folder and we open up the source folder, we have these repositories folder here. So we can create a repositories folder and we can have our base stuff in here. And this is where we're going to have both the repository and the interface, which correspond with one another for the base. So in the base interface, we can firstly, what we want to do is we want to use TypeScript generics, because the idea is we can pass in whatever entity we need here. So for example, we'll see the user entity being passed in here, and then that repository will have access to all the data layer based on the particular service or area that we're in. So this will come clearer as we work on this. But here we see, let's say we want to create something. So we want to create a new resource. So T is the generic, and that can represent the user entity, for example. Now we've got this deep partial type here because we might not necessarily need to, include all of the properties. So for example, we might not need to include the ID when we're creating a resource. So we can have this deep partial where it's, it basically sets the properties to being optional. So that way we can have the entity defined, but then we can also, pass in or not pass in the optional properties. And the idea of this is we're decoupling the user stuff from the actual data layer itself. So we can see that when we create our repository based on this interface that, we'd only need to change in the one spot if we wanted to change our ORM or, perhaps create raw SQL things where those methods aren't used throughout our entire application. So, let's just create some of these signatures here. So we want to create a resource. We can take whatever the data type is and return it. We might want to create many. So this is exactly, a similar sort of thing, but we're just returning and taking an array of resources. We have a save method here, which is similar to the create method. We have a save many, which is sort of like the create many. Obviously, there's subtle differences, which you can learn about in the TypeORM documentation. But again, we're not necessarily going to be tied to TypeORM. Yes, we are using TypeORM, but let's say we want to move to Prisma or something else, we can still call these methods from, for example, a user service or one of our other microservice services. And then we can just change the coupling in the actual repository itself. So it's super handy, super clever pattern here. Find one by ID. You take an ID. Our IDs happen to be numbers here, but if you're using Mongo or something like that, it might be a string. And that just basically finds it by the ID and gives you back the resource. Find by condition. This is a similar sort of thing. But you can have your where clause in to sort of filter things. And there's this find one options type here, which helps you do that. Find or, similar to find. And you can also pass in options and they'll find multiple records or rows. Remove, that's just deleting something. Find with relations, this is something you might need if you need to do any joins or anything like that, where you can actually just pass in the relations, which again, this is coming from the Type ORM. Find many options type here. And preload. So you can just preload the particular entities. So this is essentially the interface. So this is just like the signature for all of the methods that we're going to use. And the actual, connection, let's say, to the ORM or the actual coupling to the ORM is done in this base repository here. So we see that we're exporting an abstract class and we've called it the base abstract repository. And basically, we want to use or extend this has ID property here, which is just having the ID on each of the entities. And the reason for that is because we might not necessarily have the ID on the actual type itself. Because, when you save a record, for example, you don't need to pass in the ID. But the actual entity itself or the actual, in the data layer, in the actual database itself, it will have a corresponding ID. So we just go ahead and extend that. So we can have this generic type here, which just extends that, just to make sure that we have that property on it. Some of them will already be defined like that, but this just takes care of the cases that don't have that explicitly written. And then what we want to do is we want to implement the base interface repository. So we just created that. We created this generic type here, and then we can pass in our particular repository or entity into that here. And then we can see that the base abstract repository is going to have all of those that are on the entity itself, and then plus the ID if it's not already included. And then we're implementing all of these base methods that Type ORM give you. So for example, firstly, we need to use the constructor to inject the particular entity that we want, which we normally do this in the service, or we have been doing in the service, but again, we're decoupling the data layer from the service itself. So that's why we have the repository here, and we're implementing a generic interface for the particular entity that we're using. And then we're just, setting this entity to the entity such that we can use it from within this abstract repository. Or this abstract repository methods will be used in a subclass, let's say. So we can see already that the signature here matches the signature here. So here we've got the save method here. And we can see that it's also taking the deep partial and return the same type. So that's all well and good. And then this is where we're actually doing the Type ORM specific stuff. So in Type ORM, There's a save method, for example. So when we, make use of this and extend this abstract repository, wherever we extend it, it will refer back to this one spot. And that's really, really nice in case we do change the ORM and then we're not coupled in all of our places. And let's say we have a big application, and it probably would be in a microservices architecture. You have multiple people and multiple teams working on multiple services. If you were to make a change, let's say your SQL queries are suboptimal and you just find a way better ORM, or even if it's just like you're writing raw SQL yourself based on the same method, you can just make the changes in this one spot. So this is sort of a problem that you solve after a couple of years of development, or something you become aware of, if you build a system and then you need to make these changes, because it is a real thing where if you're needing to make like a search query, for example, you have millions of rows of data, you got some complicated joins, you might have a 5-10 second query, which is obviously not acceptable because the ORM, while it's really good at some of the simple cases, and it's getting a lot better at some of the more complex cases, there are still some really complicated queries that you might need to override with raw SQL. And if you've already set up your system and you might not be fully aware of those until a later point, this is where the decoupling becomes really important. So it's a really, really great pattern, really, really clever. And then, of course, we can implement the other patterns. So we got the save many. This is basically the same underlying method here. We got the create, which is just calling the Type ORM's create here. Create many. Find one by ID, which essentially it takes the ID, which is a particular type of option, and you can find that particular row for the entity based on that ID. Find by condition, a similar sort of thing, but you're finding based on the filter condition. Find with relations, so you can just put in that as well. So these are all based on the find one options. This is coming from the Type ORM. So again, the abstract repository, this is tied to the particular ORM implementation. So we're using TypeORM, but you can see that, like, let's say we switch to Prisma. I don't know what Prisma's methods are called, but let's say, find one by was just find one. You could just come here and change that to find one and use that. Or if you wanted to write your own SQL query, you could use the query builder and write some raw SQL. But as you can see, you can make the change in the one spot, and then they'll propagate throughout all of the places that it's used throughout the application. So find with relations, find or, it's using the find method here to return the array here. Remove, it's just deleting the resource. Preload, you can preload the entity or entity like. And it's important to note that you can obviously extend this. You can have more of the ORM specific stuff in here if you need that. But these are the main sort of CRUD operations. So I'll have these in the base repository here. So now that we've set up the base repository, let's actually have a particular implementation of that. And as we alluded to earlier, we'll do that for the users repository to start off with. So let's start with the user repository interface. Now, the user repository itself, it's going to have all of the methods that come from the abstract repository. And we do that just by extending the abstract repository for that particular entity. So we're doing it for the user entity. So recall the user entity has an ID, first name, last name, email, password. So based on that entity, we can see that if we come to our abstract repository method, it's simply going to put the T in for the particular entity. And obviously the benefit is we can use any entity on this, and the entity or the repository here won't be coupled to the ORM because we're using it through this abstract class here. So we don't actually need any other methods because the abstract methods that we have here, this is going to cover pretty much everything we need, but it's notable to note that let's say we had some very user specific stuff here, we could easily just create a class in here, and we could a function in here in the interface, and we could do a similar sort of thing in the corresponding repository. So in the repository itself, we just have this class, we call it users repository. This is going to extend the base abstract repository with the user entity type, and it's going to implement this interface here. So this interface here, it extends the base interface, and optionally, or perhaps not in this particular case, but in other implementations of the repository method, that we may actually have some extra functionality there, depending on our business rules and use case. So let's just go ahead and use a constructor here, and we can inject the repository. So we inject the user entity, and we can just pass in the repository as the generic type here. And then since we're doing this extension here, we can actually just call the super method in the constructor. So they'll call the constructor in the abstract repository, and that will allow us to sort of make use of whatever particular entity we are, so the instance of the entity, such that we can call all of those ORM methods there. So we do the same sort of thing for the shared service. So we created the shared service before. And one thing to note is I've actually moved the users repository, the user entity, and this user interface here. This is all in the shared, because the reason for that is because it's not just the auth module that will need the user related stuff. It's actually pretty much all of the microservices, they may need information relating to the user. So just in case you were wondering why those files got changed there. But essentially what we're doing now is we want to do a similar sort of thing for this shared service here. So we see that we've got this acknowledge method here, get RMQ options here. So we can just come here in the interfaces folder here, and we can just pretty much copy the signature here, such that we have our interface that we can implement there. So just go ahead and do that there. And then what we need to do, now that we've got the base repo set up and also the user repo alongside with the shared stuff here, we can inject that into our auth module. We can use it as a provider, and we do this in a slightly different way. It's a little more sophisticated than it was before, but essentially we can have the provider here, and then as a provider we can use this provide, and we can label it something. So in this case we're going to call it the auth service interface here, and we can go ahead and use the auth service class here. We do a similar sort of thing for the user repository. So the user's repository interface here, and actually I think we may need to come back to this, where this came from. But the user's repository interface we created, and the user's repository is the particular class that we're using. And then likewise with the shared service, we have the shared service interface that we're providing based on the shared service class. So let's just jump over to the auth controller. We'll come back to this auth service interface. So basically the auth controller, it's very, very similar to how it was before. We just made one alteration to how we're injecting in the constructor. and we see that we're injecting it based on the name. So that corresponds with what we've called it here. So we've provided it this here. And the particular class that we're using is the auth service itself. So that pretty much stays the same as it was. We do the same thing for the shared service. Let's just make sure that our interface, well, firstly, we have an interface, and then the contract of the interface matches the implementation from the actual class or service that we're using there. And then we can just use the methods the same way as before. So in the auth service here, in the constructor here, we're doing a similar sort of thing where in the service itself, we need the users repository stuff. So we just go ahead and we inject that based on the interface here. And that user repository is of the user repository interface type. So that's handy too. And then we got the auth service interface itself. So this is something that this is the final piece here. So we have it, the interface, the auth service interface. And this is just going to, if we look at the methods here, we've got get users, find by email, etc., etc. This is where we're just writing the signature out for all of those such that, you know, the contract for the interface matches the service because we're implementing the interface for that class. So we can just go ahead and add all those in. You can pretty much just copy the method just like that and copy it in. So I'm just going to go ahead and paste these in. So you've got find by email, hash password, register, does password match, validate user, log in, and verify JWT. And the final thing that we've done here is, all I've done here is we've created a bunch of extra files in here. I've just gone ahead and I've just organized these as imports here. Oh, sorry, exports here. And what that allows us to do, so you can just copy these in. But what that allows us to do is, for example, in our files here, like the auth controller, we see that we've got this shared service from app shared. And that just saves us from having to do the, you know, all those imports where it's slash shared service. And, you know, if there's nested folders, since we now have nested folders, you know, we want to avoid having really long file paths. And then also we can, if we need to, we can import multiple files from the same area. So let's just check that everything is working. So let's go ahead and open Postman here. So let's just try and make a API call to auth. We get our users back. Presence, we get the 403. Let's try logging in. We get our JSON Web Token. So the auth service definitely works. API gateway is obviously working. And then finally, let's just check the presence token by putting the JWT to make sure that microservice is still working. And then we get our resource here. So in a nutshell, that's the abstract repository pattern implemented in NestJS. It's really quite a powerful pattern when you think about it. And it's really clean. It structures your code a lot better and decouples the data layer from your business layer. So if you found that useful, please subscribe to my YouTube channel. In the next video, we'll start to look at a little bit of setting up authentication in React Native and how React Native works. And of course, if you want to contribute in any way, I'll be super happy if you want to collaborate and keen to see any PRs or, just get in contact with me if there's anything in particular. And thanks so much for watching. Cheers. I'll see you in the next video.